Hey, good to be back. Welcome back to your favorite pre-calc class. We got section 3.4 here, build quadratic models from verbal descriptions. We're going to, that's our first objectives, and also use some data to build some quadratic models. So let's say we have our first example here. We got this farmer with 1,600 yards of fence. He wants to enclose a rectangular field. So let's get my drawing. So we've got this rectangular field. Let's call our length X, our width W. And we know the total fencing that we have to go around this thing is 1,600 yards. So number one, our perimeter here, you got X plus W plus W. So you got 2X plus 2W for the perimeter and 1,600 total yards to do this. To build this fence with. And what we're trying to do is find the dimensions to maximize this area, this rectangular. How long should we have this, and what's our width for that? Well, we also know that area is length times width, or in this case X times W. And so in order to maximize this area, what we're going to have to do is build a quadratic model here. So we're going to have to use our perimeter equation there with the 1,600 to make a substitution. So if we solve that first one here, if we solve this for W, we got 1,600 minus 1,600, sorry, I don't have much room here, minus 2X equals 2W. We divide everything by 2, so we get 800 minus X is our W. Okay, so what we can do is now that we have what W is equal to, we can just substitute in right there. And then we'll build a quadratic in order to maximize the area. So we got area is the length X times our W now, which is in terms of, right, so what we did is we took our perimeter there, solve for W. W is in terms of the length, 800 minus X. So we just substitute there, so substitute in. Go ahead and multiply this through. 800x minus x squared, but what I'm going to do is put this in standard form here with the negative x squared first, plus 800x. Okay. So now we're trying to maximize area. So we know for a quadratic function, right now we're to the x squared here. For a quadratic function, let me give you a picture of this. Whatever this looks like, we've got this quadratic and we're trying to maximize it. Where does this maximum occur? Well, if you recall, it occurs at the axis of symmetry, which is at the point x equals negative b over 2a. X equals negative b over 2a. Well, this is our a here is 1, and our b is 800. Of course, our c is 0. So we're going to throw it into, so number 3 here, find our axis of symmetry, negative b over 2a. So x equals negative 800 over 2 times a. So negative 800 over negative 2, we got 400. So 400 is how long we want this thing to be. 400. Okay. Let me erase some of this stuff here. So now we've got if x is 400, let's go back to our perimeter. 1,600 equals 2x plus 2w, and then we can find our width so that we have our dimensions. Right? Our length has got to be 400 yards. Oops, that's a 2w right there. Subtract the 800, subtract the 800. So we've got, oh my gosh, making a mess here, not much room. 800 equals 2w, and we've got, our width ends up having to be 400 as well. Okay, so we got a 400 by 400 is the ideal or maximum to maximize our area. 400 length, 400 on the width on that thing. Okay, let's look at another example. Let's say we've got a projectile fired from a cliff 500 feet above the water at an inclination of 45 degrees to the horizontal. I got a picture of this here in the next slide. with a muzzle velocity of 400 feet per second for physics. The height, so we've got h, our height here, of the projectile. Both water can be modeled by there's the equation where x is the horizontal distance out, right? So we've got this thing, it's a quadratic. You know, you're shooting this thing from a cliff 500 feet above the water, right, at a 45 degrees. So shooting out, this is our x distance out, and h of x is how high you're at based on how far out. You know, if you're out 20 feet, you plug it into the equation, you figure out how high you are. Okay, so find the maximum height of the projectile. We're going to do this orally. So find the height. You know, how far out are we going to be? Well, once again, we've got this quadratic equation, and we know our maximum occurs, where does it occur? On the axis of symmetry. So we're going to plug it in, negative b over 2a. So we just identify what our a and b are. And I'm looking at this, and I'm like, well, all right, that negative 32 over 400 squared, there's our a. Our b would be 1. Of course, our c is 500. So we go back to that, and we plug it in, and we find out, here's the equation where we plug it in. So we got negative, our b again is 1 right there. Right, get your b right there over 2 times, and this reduces the negative 32 over 400 squared. That's negative 1 over 5,000 there. You just work that out, and you end up with x being 2,500. So if it occurs out here at 2,500, then what's your height up here? You know, how high are you on this thing? Doing that for me, dang it. How high are you? Come on. There we go. How high are you? Then we just plug it into the equation for x. Just plug the 2,500 in for x, plug the 2,500 in. It looks like it's a 1,750 feet on that. Okay. Now, part B. When will the projectile strike the water? Well, whenever your equation is equal to 0. In other words, when is your height, right? If you've got this picture here, when is your height 0? Well, it's got to come down. You want your height to be 0, so we replace h of x with 0. So then we're just solving this here, and then you plug it into the quadratic formula is what I would do. So replace your a, b, and c, and you get 2 solutions when you plug that into your quadratic formula. And I'm not going to take the time to do that with your calculators, but you can plug that in with your a, b, c. And you get 2 solutions. Is it negative 458? Well, no, it's not a negative value. You've got to be out a distance. A positive distance is always positive. So it's out a distance of 5,458 feet. That's when it'll hit the water there. Okay. All right, now let's build some quadratic models from data. If you have a bunch of data, you know, and if your A is positive in the model, you're going to have the parabola opening up, whereas if your A is negative, you're going to have this parabola opening down. These are examples of some quadratic models built from data. We're going to look at one here that represents the percentage of the population that is divorced for various ages in 2012. So we're going to punch this in. Here's going to be our input here, our x. Here's going to be our y, the percentage divorce. So at age 22, there's 0.9% divorced. Whereas at age 50, 15.7% of the population is divorced, and so on. So I'm going to punch this in to Desmos. So what you want to do here is go to your mouse here. Where's my mouse? Go to Desmos.com, click that plus there, and you're going to enter your data right here. Let's see, data was, I gotta go back here, dang it. 22, 27, 32, 37. And then I've got 42, 50, 60, 70, 80. got 0.9, 3.6, 7.4. And then we've got 10.4, 10.4, 12.7, 15.7. 10.4, 12.7, 15.7. And then we've got 16.2, 13.1, 6.5. Alright, so get your data in. And then what you do is now, and you know what, let me zoom out a little bit. It'll show your data here. Kind of move this over. Maybe I'll blow that up a little bit. Back up. Okay, so whoops. So you can see the kind of the quadratic there. And what we're trying to do is we're trying to build, using quadratic regression model here, trying to find what the equation is for this. And we're going to have our computer do that regression for us. We're not going to talk about the statistics behind the algorithm for what the computer's doing here. If you want to take a statistics class, you can get into that. We're just trying to build a model. So what you do is if you look up here, you see how this is your Y1 data and your X1 data. So what you got to do is you got to name this Y1, and you got to use your little squiggly there, approximately AX1, because you're using your X1 data, plus BX1, again you're using your X1 data, plus C. So you put in standard form there, and what it does is it gives you, oops, AX1 squared, I'm sorry about that, AX1 squared, there we go, plus bx1 plus c. Sorry about that. ax1 squared plus bx1 plus c. And let me tell you where I see most students messing up is they forget the little squiggly, or they'll forget the subscripts. X1 subscripts or the Y1 subscripts. You got to have those subscripts to tell it to use the data that you just punched in. Okay. And then notice right down here, you see how it's giving you the A1, the A, the B, and the C. Okay, so negative 0.014, 1.586, and you got negative 28.19. So now you can write the equation for your quadratic equation that models the data. Okay, so if I go back, and then we're gonna, there's your A, B, and C. That's just a look from a TI-84 there, using the quadratic regression, so you can write it. So now you're like, oh, well, the divorced percentage divorced is, you put your A in right there. Get your A right there, x squared, you get your bx, you get your c on the end. So after you write the equation, based on the quadratic function of best fit, the age with the greatest percentage divorced is, now you just go to the x equals negative b over 2a, and you plug your b in, you plug your a in, and the greatest percentage divorced is at 55 years. What's the percentage? Then you just plug it in right here, plug the 55 in, back in. So 55-year-olds have the highest percentage divorced at 15.8%, and so that's it. In fact, you can click right here in Desmos. It'll allow you to, if you click on that, right, it'll show you that gray dot right there. That'll give you the maximum height right there, and that's what it's doing. It's plugging in the negative b over 2a to find that 55. Oops. Find that 55 right there. All right, thanks for listening, you guys. We will see you in class.